Throughout our history, humanity's threats have primarily come from terrestrial entities. But in 1994, we witnessed something that shook us to our cores. Comet Shoemaker-Levy 9 slammed into Jupiter's surface, causing massive damage that still affects the planet to this day. What if Jupiter's gravity hadn't caught the comet? What if it sailed past the gas giant and collided with us instead? This is Unveiled, and today we're answering the extraordinary question, what if Comet Shoemaker-Levy 9 hit Earth instead?
Are you a fiend for facts? Are you constantly curious? Then why not subscribe to Unveiled for more clips like this one and ring the bell for more fascinating content?
Spotted in March of 1993 by astronomers Eugene and Carolyn Shoemaker and David Levy, Shoemaker-Levy 9 was the first comet found orbiting Jupiter. By that point, it had already been torn into 21 pieces and was near the end of a potentially decades-long orbit. It's estimated that the original intact comet had a nucleus of over 1 mile across. For perspective, it's thought that the asteroid that wiped out the dinosaurs was roughly 6.2 miles in diameter, but the size of SL9 was more than large enough to cause massive damage. Indeed, we had front-row seats to watch it rain destruction down on Jupiter. Over the course of 6 days in July of 1994, astronomers watched in awe as pieces of SL9 slammed into the planet. This event shook up not only the scientific community, but also governments and the public, hammering home the possibility of a world-ending event coming from the sky. It's no coincidence that only a few years later, Hollywood produced not one, but 2 movies that dealt with that scenario, Armageddon and Deep Impact. It's no surprise that SL9 captured the imagination when you look at the effects it had and continues to have on Jupiter. In total, there were 21 impacts on the planet's surface, with a combined force of 6 million megatons of TNT. To put that into perspective, the entire world's nuclear arsenal at its peak in 1974 had a potential yield of 25,000 megatons. These impacts left huge bruises on the planet, including one the size of Earth. While these scars gradually faded over time, their influence still affects Jupiter to this day. During SL9's bombardment of Jupiter, the Galileo probe was also on its way to the planet and captured some truly stunning images of the destruction. However, once Galileo got closer to Jupiter and began studying its atmosphere, we started to truly understand the extent of SL9's carnage. First in 1996 and then again in 2000, Galileo took images of a pair of superimposed ripple patterns in Jupiter's faint rings. Upon studying the pictures in 2011, researchers from SETI and Cornell University determined that the massive impacts from SL9 had caused the entire ring to tilt by over 1 mile. The comet itself never crossed through the ring. Instead, the collisions alone shot enough cometary dust into the atmosphere to alter the ring permanently. What's more, in 2013, US and European scientists discovered that a whopping 95% of the water found in Jupiter's upper atmosphere came from SL9. So clearly the comet has had lasting effects on the planet. But what if Jupiter's gravity hadn't captured the comet and it instead headed our way? In short, it wouldn't be good. Astrophysicist and radio astronomer Garrett L. Verschoor predicted that any impact from a comet 2/3 of a mile across would likely spell the end of civilization, and anything 3 miles or larger would probably mean the end of our species. Given that an intact SL9 was about 1.1 miles across, its collision with Earth would be disastrous. The comet would be blown into pieces on its initial strike, creating a gigantic fireball engulfing the surrounding area. Mechanical engineer Michael Payne published a paper in 2004 exploring the environmental damage from asteroid and comet impacts. According to him, a comet the size of SL9 would create a massive fireball with a 150-mile radius, effectively incinerating anything in its path. In addition, 300-mile-per-hour winds would rip apart anything within a 110-mile distance. Trees would be torn from their roots, and windows would shatter up to 250 miles away from the impact site. Flaming debris would be spewed into the atmosphere, raining down countless small comets that would burn up in the air. The immense heat would ignite forests and buildings up to 370 miles away. Earthquakes, tsunamis, and hurricanes would follow, hitting the area within hours and lasting months. That's some truly apocalyptic stuff, but that wouldn't be the end of it. The dust, debris, and smoke would plunge us into what's known as an impact winter. The sun would disappear for at least a month, with regional freezing lasting weeks. This could plunge worldwide temperatures by more than 46 degrees Fahrenheit, disrupting things on a global scale. You can say goodbye to summer that year. You can also say goodbye to the environment. The explosion of the comet would send billions of tons of sulfur-laden dust into our skies, while the heat of the impact would create nitrogen oxides. Together, they would generate a toxic acid rain that would destroy plant life. Moreover, the acid rain would find its way into our oceans and lakes, decimating marine life. This deadly downpour would last for months in the regions surrounding the comet impact. But that wouldn't be our only atmospheric concern. Given a sizable enough comet, our ozone layer would be destroyed within days, which would result in a greenhouse effect perhaps lasting for centuries. Needless to say, this would put enormous pressure on our food production. We would likely see a global crop failure and worldwide food supplies being disrupted for years to come. Food shortages, coupled with staggering environmental and infrastructural damage, would likely mean the end of civilization as we know it. Humanity would probably survive, but we would need to rebuild. However, these doomsday scenarios are all based on a land impact. Water makes up 70% of the Earth's surface. What if the comet struck the ocean instead of land? Well, it wouldn't be as bad. In 2010, the late Elisabetta Pieriazzo, a senior scientist at the Planetary Science Institute, created a model studying an oceanic impact from an asteroid. While it's still not pretty, it certainly paints a better picture than a land collision. If an asteroid about 2/3 of a mile across smashed into the ocean, it would spew tons of salt water into our atmosphere, seriously damaging the ozone layer. This would send our surface UV index skyrocketing to an unheard-of 56. To put that in perspective, a UV index rating of 11 is considered extremely dangerous. This incredibly high level of radiation would force people to remain indoors during the day. While that would still have a negative effect on our world, the kind of decimation that we would see from a land impact would largely be avoided. But wait. What about those massive tsunamis from comet collisions like we see in the movies? Wouldn't coasts be battered with those? Well, actually, no. Like tossing a rock into a lake, an impact from a meteor or asteroid would only affect the immediate area surrounding it. It would certainly send out large waves, but they would quickly lose energy. Tsunamis are only created from giant shifts in the seabed, like from landslides or underwater earthquakes. So we would definitely be dodging a bit of a bullet if a comet struck the ocean, but it still is far from ideal. That's why, in the aftermath of SL9, governments and scientists began a concerted effort to monitor our skies for any impending dangers. After witnessing the damage done to Jupiter, the U.S. Congress in 1998 mandated that NASA find at least 90% of near-Earth objects, or NEOs, 0.62 miles or more in diameter. And in 2011, NASA announced that it had done just that. However, NEOs smaller than 0.62 miles still pose a danger. In 2005, that search was refined to include NEOs larger than 459 feet and to find 90% of them by 2020. NASA unfortunately wasn't able to meet the goal. The search for objects that small requires even more resources and coordination that NASA alone couldn't handle. In 2016, the agency sought to remedy that by establishing the Planetary Defense Coordination Office. Its goal is to help centralize and coordinate the search for NEOs across different agencies and governments. NASA currently estimates that there are more than 878 NEOs 0.62 miles or more in size. While they believe they've found approximately 90% of them, there are still a great deal of unknown, smaller NEOs that could cause havoc on our planet if they collided with it. This is why scientists still remain vigilant, watching the skies for any potential apocalyptic object that may strike. And that's what would happen if comet Shoemaker-Levy 9 hit Earth instead.
What do you think? Is there anything we missed? Let us know in the comments, check out these other clips from Unveiled, and make sure you subscribe and ring the bell for our latest content.